Hello everyone. So today we want to solve this question. Add one row to the tree. Okay. So let us read the description. So given the root of a binary tree, okay, the value v and depth d. Okay. So there are two values they are given. You need to add a row of node with the value v at the given depth d. The root node is at depth 1. Okay. The adding rule is given a positive integer depth d for each not null tree, okay, n in depth d minus 1, create two tree nodes with the value v as n's left root subtree root and the right subtree root, okay, and n's original left subtree should be to the left of subtree, and the new left subtree root, its original right subtree should be on the right subtree of the new right subtree root. If the depth d is 1, which means that there is no depth d minus 1 at all, then you need to create a tree node with the value v as the new root node of the whole original tree, and the original tree should be new roots left subtree. Okay, so what they are giving, what the statement is saying is, so let us take this example to understand the statement. So you can see this is the root, okay, and we have some values to the left and right, and we are given the value as 1 and depth as 2. So at the root depth is 1, this is depth 2, this is depth 3. So at the depth 2 we are going to put this value v, which is 1. So our resultant tree should be like this 4, okay, then value at depth 2 is nothing but 1. So for the left it is 1, for the right it is 1, and for the left this should remain the same. So basically we are going to put as it is 3 1, and for this one we know that is 6 is there here and 5 is here. So this is the resultant, basically the tree. Okay, so this is we need to show them as output. Okay, let us scroll down and see the output. So you can see this is what the tree we have drawn here, same tree. Okay, so let us see the another example. So same here we are going to see that the value is 1. Okay, the value is 1 here and depth is 3. So this 1 is 1 2 3. So here 1 2 3, this 2 value comes and this 2 3 remains the same. Okay, and you can see, suppose there is a tree like this 4 2 3 something, and it's taking the random values. Okay, and we are given depth equal to 1. At depth equal to 1 we need to give value as 3, any values. So what will the resultant will be like this, it should be a 3, and on the left it should be the whole tree as it is. Okay, so let us try to understand the code here. Okay, so what we going to do is, first we are going to take the base case in which we need to put something at t equal to 1, or basically at the root we need to put something. So we are given the value, we are given the depth. So first we are checking if depth equal to 1. Okay, in that case what we need to do, so suppose this is the tree, let me reduce the size, and so suppose this is the tree, okay, 2 1 something like that. Okay, this is the tree, and we want we have some value like 3 and depth equal to 1. Okay, so in this case, in that case what we need to do, what we are doing here, so first we are creating a tree node t1, we are calling that node as t1. Okay, so suppose that is t1 here. Okay, we are calling this as t1, and what is the value for that? So the t1's value is whatever the value we are getting. So here the value is 3, so we are storing that value in this. So this is basically the t1. Okay, and then what we are doing, t1's left should be the root. Okay, so this is basically the root of the tree, original tree, and t1's left should be the root. So basically we are connecting this. Okay, and then what we are returning, we are returning the t1. So now the t1 is this one, now this whole tree will be returned. Okay, so this is the base case, and in other cases when this is more than 2 or something, so we are just calling this function fun. Okay, in this what we are passing root value and d minus 1, because we need to this is basically the original d, which is 1. If it is not 1, then we are going to see for the other values. Okay, so it is already starting from 1, so for 2 for 3. Okay, so we are just reducing the depth and we are passing. Okay, so basically if we have some value 3, so at depth equal to, when depth equal to 2, so basically it will go here, so it will change that. Okay, So let us see the fun function here, what basically they are doing. So this is the fun function. Okay, so in this what we are doing, we are checking the base condition, which means at depth equal to 1, because where we are starting our iteration, we basically the depth of that root is 1, that's why this d equal to 1 is the base case. Okay, so here we are seeing if d equal to 1. Okay, so in that case what we need to do, we need to create two nodes, basically three nodes. One is for the left and one is for the right. Okay, so left goes the value v and the right also goes the value v. Okay, and what we are doing, t1's right should be the roots right. Okay, and t1's left should be the roots left. Okay, and then we are doing root tends to left equal to t, and then root tends to right equal to t1 here. Okay, and then we are just returning the root. And once we are done with this condition, we are calling the again we are calling this function fun with the roots left value, v value, and the d minus 1. And for same we are going for the right, so v and d minus 1. Okay, and we are updating that root tends to left and root tends to right, and we are just returning the root from here. Okay, so this is the basic idea of the question, add one row to the tree. So I hope you got the basic idea of the code. So we'll meet in the next video with another problem. Okay, so thank you for watching. If you like the video, just go and like the video and subscribe to the YouTube channel. Bye.